Hello, detectives. I've been instructed to inform you of orders from our Commander-in-Chief. First orders. You're needed to analyze the solvent effects on reaction rates using the methods of microtitration and graph plotting. We need to understand the chemical kinetics and reaction mechanisms of the SN1 reactions.
The chemical reaction shows the production of HX, X being the halogen of choice. Because HX concentration is proportional to the amount of substrate left, the amount of substrate consumed at a time point of the reaction can be determined by quenching it with isopropanol and titrating it with NaOH. The volume of HX can be determined since the amount of NaOH is equivalent to it, so we can find the concentration of H+ using our equations here. The endpoint of the titration, indicated by the color change thanks to phenolphthalein, occurs at the equivalence point, when the amount of acid equals the amount of base. This is important because we can now know the concentration of H+ relative to time, thus being able to see which integrated rate law graphs match the order of the reaction. Why unimolecular and not bimolecular? Because tertiary substrate with a good leaving group favors unimolecular reactions. Why substitution and not elimination? Well, for unimolecular reactions dealing with tertiary carbocation substrates, the substitution is generally favored. This is how we expect the mechanism to look like. The loss of leaving group followed by a nucleophilic attack by the water, and then a proton transfer from water, leaving us with an alcohol product as well as its acid. So, this is how the rate law looks like, because the rates of the reaction of substitution via nucleophilic attack on a tertiary carbocation are proportional to the concentration of the substrate itself, while also being independent of the nucleophile's concentration. The transition state only shows loss of leaving group, the slow step that determines the rate of the reaction. The purpose of isopropanol as a cosolvent to water is that isopropanol acts as a polar protic cosolvent which helps the hydrophobic substrate dissolve while also being relatively miscible with water. The purpose of having various ratios to isopropanol to water is that the more polar the solvent mix is, meaning more water in the ratio of isopropanol to water, the rate will be ever so slightly more faster because high concentration of water will help shift the reaction to the right.
These are the materials you're going to need. 7 test tubes, 1 125 ml Erlenmeyer flask, 1 10 ml graduated cylinder, 2 50 ml beakers, 1 150 ml beaker, 2 400 ml beaker for the waste, 1 micro syringe, 1 plastic pipette, and 1 Eppendorf micropipette. These are the liquids you'll need. 2 propanol, 0.040 molar NaOH, phenolphthalein, your assigned ratio of 2 propanol and water, and whatever substrate you're going to be using.
Let's get started. We need to prepare this siren here. First of all, we have to cut the top of the plastic pipette. Let's condition it with a base. And put the solution in the waste container. Add the plastic pipette to the top of the syringe. Here we go. Perfect.
Not perfect. Remember to snip the tips before you're doing the titration, so there won't be any bubbles.
Now we prepare the test tubes. So what you're going to need is 1 milliliter of 2-propanol and 2 drops of phenolphthalein in each of them. So, using this automatic pipette.
Now it's time to make the reaction happen. There's only so much time. You gotta be fast.
Put this assigned solvent mixture, 10 milliliters of it, into your Erlenmeyer flask. Got it?
Now we're going to need the professor to put the substrate into the solvent. Make sure you have your timer ready.
Swish, swish, bish. Another one in the basket.
Alright, time to make the first sample. Don't get the air bubble into your sample. Add the base into the tester. Make sure there's no air bubble in it. Then shake it until the pink is go away. Then add more base. If the pink doesn't go away, then your reaction is finished. Note your final volume.
Don't freak out when you run out of NaOH. Just know the value and get more.
So at 10 minutes, we collect another 1 milliliter of the sample and titrate the next solution. About 7 plot points should be obtained per solvent.
Now that we've already done the chloro substrate, we need to use the substrate for the bromo one.
After data is collected, find which graph, according to the integrated rate law, has the better R-square value in order to provide the evidence for a first-order reaction. Here is an example of how your graphs may look like. Get your conclusions now.
And we did all this with the help of our microtitration laboratory techniques. Now we know!